him. Hey guys, MediaNutso here, and welcome to the first one. Sorry, and welcome to the Pokemon Learning Week Tuesday. Now, for those of you that missed it last week, we covered the first 5 lessons in the science category. Well, for this week, we're going to be tackling the first 5 lessons in the math category. Consisting of types of angles, PEMDAS, fractions, discounts, and area of a circle. Now, we're going to sorry. Well, enough of my stuttering on that opening line. Let's get the things going right away with the first lesson up for tonight. Types of angles. In which we will all watch how Ash and Brock are gonna learn how to put picture up a tent using the various types of angles. Ooh, how exciting.
Alright, this new tent looks sweet.
Yeah, I can't wait to camp out in it tonight.
Pikachu!
Here, you read the instructions. I'll get the parts out of the box.
Deal. Okay, so the first step says put the center red pole at a 90 angle.
90 angle? Are you sure that's what it says? It sounds kind of weird.
At a 90 angle. Wait. Maybe it says 900. But that other O is smaller. Maybe it's just an ink blot?
Let me see that. Oh, you're right. A 90-degree angle.
Okay, cool. What does that mean?
B.
I'm not exactly sure. What's step number 2?
Attach the first blue pole at a 45-degree angle to the red pole.
And then what else?
Attach the other 3 poles at a 45, or it could be 450 angle.
You gotta be kidding!
That's all it says!
Oh, brother. How are we gonna put this tent up?
I think we're gonna need some help with this. Let's use the Pokepilot to ask Ada. She knows her way around numbers.
Good idea.
Hi, Ada.
Hey guys, what's up?
We're camping and are trying to set up a tent.
Sounds fun.
Yeah, but we're having some trouble with the instructions. It's like angle this and angle that with all these measurements. I mean, I know what angles are, but I'm not sure what to do with these specific degrees.
Yeah, how can you tell what the number means?
Gotcha. Sounds like we can tackle this problem by defining different types of angles. Let me tell you, once you start looking for angles, you'll see them everywhere. Like in a room. They're in corners, at the ceiling, and on the roof. You'll definitely need some angles if you're going to pitch a tent.
Yeah, that must be what's all over the place on these instructions.
You're right. Angles are measured in degrees. That's what that little O symbol after the number means. Here, let me show you what I'm talking about. We group angles by type according to their different measures. First, we have this one. The open door is making an angle. It's called an acute angle, and it measures between 0 and 90 degrees. Now look at this corner. It's a right angle. A right angle measures 90 degrees. Did you know right angles are the most common angles?
Oh yeah, like the corners of a box.
Or the seat and back of a chair.
Exactly. Now, let's shed some more light on this subject. Let's look at this window. When it's open, it forms an obtuse angle, which measures between 90 and 180 degrees. If you open the window as far as it will go, it forms a straight angle. Straight angles are straight lines and measure 180 degrees.
All right, I think I've got what you're saying. Acute, right, obtuse, and straight all refer to angles of different measures.
Right.
I just need to remember which is which.
That's the trick. Practicing with angles helps a lot.
But wait, what's that half-circle thing you're using?
It's called a protractor, and it is used to measure an angle. Like, look at this angle. What is its measure?
Well, its pointed at 60 degrees.
Right, it's 60 degrees. So what kind of angle is it?
60 is between 0 and 90 degrees, so it's an acute angle?
You got it. And you can always get the angle. Just place a protractor over the angle to find the measure.
Awesome.
A right angle measures 90 degrees, so it would look like this.
Sure, that makes sense. The angle measures exactly at the 90-degree point.
So what would an obtuse angle look like?
You're asking me?
Yep.
Well, okay. An obtuse angle would start out just like the other two angles, but it would measure between 90 and 180 degrees.
Yeah, like this. Pika! Now you can see how the protractor helps. You can use it to measure angles and to draw angles. To use a protractor, place the arrow on the corner, the vertex, of the angle you want to measure and read off the measurement on the scale in degrees. This angle measures
100 degrees!
Right. Now to draw with a protractor. First, you draw the bottom line of the angle and place the arrow in the protractor where the vertex of the angle will be.
Okay.
Then find the degree for your angle on the scale. Let's use 60 degrees.
That works.
Make a mark at 60 degrees. Then draw a straight line between the vertex and that mark.
Hey, that's pretty cool.
You got it. You just have to make sure you get the right measure for each type of angle. Acute between 0 and 90 degrees. Right at 90 degrees. Obtuse between 90 and 180 degrees. And straight
is 180 degrees.
Right. So why don't you check out some of the angles you see around you in the woods for practice? Like that big tree with all those branches. There's got to be at least 100 angles on that tree alone.
Cool! Let's practice!
Pikachu!
All right! I'm gonna measure the angles of these branches, but I'm gonna need some help. Are you in too? Let's check these angles out. Okay, look at this first branch. I think the first angle is an acute angle. What is the measure on an acute angle?
Right. An acute angle measures between 0 and 90 degrees.
Now, how would we draw an acute angle?
Right. An acute angle measures between 0 and 90 degrees.
Let's look at another
Reminding
branch.
us of that, Ada.
I think this one may be a
I'm
right
sure-
angle.
sure some
What
of
is
us
the
didn't
measure
get
for
it
a
the
right
first
angle?
time.
Right. A right angle measures 90 degrees.
Hey, could you draw a right angle?
Right. A right angle measures 90 degrees.
Okay, look at this branch. I think it might be obtuse, but what is the measure for an obtuse angle?
Right. An obtuse angle measures between 90 and 180 degrees.
Can you draw an obtuse angle for me?
Right. An obtuse angle measures between 90 and 180 degrees.
This branch goes straight across to the other branch. They're at the same level. How cool! What is the measure for a straight angle?
Right. A straight angle measures 180 degrees.
Can you draw me a straight angle?
Right. A straight angle measures 180 degrees. That's a straight line.
Hey, thanks for helping me practice.
Pikachu!
It's starting to get dark, and I think we're ready to set up the tent now.
Yeah, let's do it. Let's check.
Well, here's a drawing of what it's supposed to look like. Help me find the angles in it. For each correct angle you find, I'll get to put together another part of the tent. Find a straight angle. You got it. Find an acute angle. All right. Find an obtuse angle. Awesome! Find a right angle. You got it. Find another obtuse angle. All right! Find another right angle. Way to go! Find another straight angle. You got it. Find another acute angle. All right! Find another right angle. Awesome! Yeah! We did it! The tent is up and ready to go! To sleep in! Hey, Ash, Pikachu.
Since we learned about angles, everywhere I look, I see angles.
Huh? Yeah, I guess you're right.
Like Pikachu. Look at your tail.
Pika?
Let me get a closer look.
Well, it looks like you're pretty much in a straight angle now, Ash.
Very cute, though. That was definitely one of the simpler lessons they ever did. But now it's time to move on to lesson number 2, which will find Ash and May learning about the orders of operation, aka a PEMDAS.
Stealing the stash of Pokeballs from Professor Oak's lab was a brilliant idea.
Thank you. I can't wait to give all those Pokeballs to the boss. Giovanni will love us so much.
We'll have a delicious feast to begin.
And get a big promotion at the end.
Is that Professor Oak?
Let me see those. Oh, that's an oak tree, not Professor Oak. The coast is clear. Let's go. Will you two speed it up? It's so heavy. Are you helping at all?
Well, I would if I could see where I'm going.
Close the lid.
Well, I did close it.
I didn't say drop it. There'd better not be any damage to our loot. Open it and check.
I don't know why it won't open.
It was just open. Can't you do anything right?
Pardon me there.
Let me at it. I think it's locked. There's some sort of combination.
That's just a bunch of number mumbo-jumbo. What sort of newfangled luck is this? There must be a key to open it.
What key?
I don't know. Maybe it dropped. It's gotta be around here somewhere. Let's spread out and start looking.
But what if we can't find the little bitty key?
We have to find a way to open the lock any way we can. Now, fewer questions, more looking.
I can't believe all the Pokeballs are gone from Professor Oak's lab.
Why would somebody do this to Professor Oak?
Pika! Well, whoever that somebody is, they can't be up to anything good. Come on, let's see if we can find the missing Pokeballs and help Professor
Couldn't
Oak.
have figured out the
Look,
obvious by now.
Professor Oak's chest. That's where he kept the Pokeballs. They should be in there. We have to check it out. Let's open it.
But it's got a puzzle on it, with numbers.
Maybe if we solve the puzzle, the lock will open?
Maybe, but how? All those numbers and symbols, what do they mean?
Let's call Ada for some help.
Ash, May, what's up?
We need your help. We've got to solve this number puzzle fast.
It has plus and minus signs all over it, and we're not sure where to start.
No worries. If you have math problems like the ones in your puzzle, where there are plus signs and minus signs and division and multiplication signs and so on, there's a rule that tells you what to do first.
Apologies for the
Maybe
lag in the
that'll
video.
help us open the lock.
Well, it's just the software is just kind of acting up a
It's
little
called
bit.
PEMDAS. These are the first letters of the steps you follow when you solve this kind of math problem. P stands for parentheses. E stands for exponents. M for multiplication. D for division. A for addition. And S for subtraction.
Those are a lot of steps to remember.
You're right. But some people remember PEMDAS by saying, "Please excuse my dear Aunt Sally." Don't worry, you'll get the hang of it. I'll talk you through the first problem in your puzzle. First, do you see parentheses?
Yeah, the 6 and 4 are inside parentheses.
Exactly. 6 times 4. You solve that part of the problem first. 6 times 4 is 24. Now, do you see exponents in the problem? It's a number that is on the right of a number, but raised a little above it.
Yeah, by the 5 there's a 2.
Perfect. That's 5 squared. The 2 is an exponent, so you solve that part of the problem next. 5 squared equals 25. Now, do you see multiplication or division signs?
Yeah, a division sign.
Right. 25 divided by 5.
And I see a multiplication sign.
You got it. 5 times 2.
But which one do we do first?
If you have a multiplication sign or a division sign, you do them in order from left to right, like when you read. So, since 25 divided by 5 is the furthest to the left, you work that out first. 25 divided by 5 equals 5. Then you multiply. 5 times 2 equals 10. And now, do you see addition or subtraction signs?
There are addition and subtraction signs. So we'd go from left to right again?
Yes. 24 minus 10 is the furthest to the left side, so we work that out first. 24 minus 10 equals 14.
And finally, 14 plus 10 equals 24.
Right. So 24 is your answer.
All right.
If we follow the order of operations, PEMDAS, we'll be able to solve the puzzle and open the lock.
Right. But keep in mind, if you don't follow PEMDAS, your answer could turn out wrong.
Got it. We gotta do this quick since the thief might be nearby.
Thanks, Ada.
Anytime.
Let's hurry and open the chest.
Stealing the step.
Take a look at the puzzle.
Highlight and click. Highlight and click on the part of the math problem you should solve first.
Take a look at the puzzle.
Highlight and click on the part of the math problem you should solve first. Yeah, 4 times 2 are in parentheses, so we work that part out first. And that leaves 3 squared. We'd work that out last.
Let's do the second one.
Well, you're right that multiplication or division come next, but you have to work.
Yeah! 16 divided by 4 goes first, because it's a multiplication or division sign, and it's furthest to the left.
Now highlight and click on the part of the problem to solve next.
Yes! Multiplication, and that comes before addition and subtraction. We're getting there.
Highlight and click on the part of the problem you should solve last.
Yeah! We add 2 plus 3 last.
One more problem to go. Let's try this one.
Highlight and click on the part of the problem to solve first.
Yes, we add 3 plus 4 first because they're in parentheses.
Which part should you solve next? Highlight and click on the part you should work on now.
Child's play.
Yes! 2 squared, because exponents come after parentheses in the order of operations.
Let's keep going.
Highlight and click on the part to solve last in this math problem.
Yes, 9 minus 6 is subtraction, and that's last.
Yay!
Awesome! We're ready to crack this puzzle and take back the stolen Pokeballs to Professor Oak.
I've got an idea. You work out the 3 math problems, now that we know how to solve them. and we'll stay on the lookout for the thief. Then we can bring the Pokeballs back to the lab as soon as we open the chest.
Take a look at the puzzle.
Highlight and click on the part of the math problem you should solve first.
Here's the puzzle. Here's the puzzle.
Start with the first math problem. You might need scrap paper and a pencil to solve it. After you solve each problem, click on the key that matches your answer. Great work! Click on the key that matches your answer. All right. Click on the key that matches your answer. Great work!
Awesome job!
Yes! Let's take the Pokeballs back to Professor Oak, but leave the box here to fool the thief.
That's it. I'm sick of searching. We'll get that lock open, even if it takes a blowtorch. Huh? I guess it just needed some of Meowth's magic claws.
The Pokeballs! They're gone!
Team Rocket! We should have known it was you!
Yeah, you really should have.
How did you get the lock open? It was foolproof!
Let's just say we had a little help from PEMDAS.
Who's that? Another twipe?
Maybe this PEMDAS person has some Pokemon we can steal and add to our collection.
Yes, nothing for us here. PEMDAS, you now have Team Rocket to fear!
That lesson was certainly more amusing than Types of Angles was. Anyways, on to lesson number 3, and it just so happens to be one of the very first lessons ever produced, and also happens to be one of the shortest. Yeah, I think you could guess what the number 3 is. Yep, we are dealing with fractions.
Hey, May, it looks like our Pokemon are getting hungry. Maybe we should take a break and give them a snack.
Oh, just our Pokemon, huh?
Hey there!
Glad you could join us. We're just about to give our Pokemon a snack.
Uh-oh. How are 4 Pokemon gonna share one berry?
Good point. We have to make sure they each get an equal piece, or we'll have some very upset Pokemon.
Let's see if we can get some help on this.
Ada at the Learning League lab is really good at solving problems. She'll be able to help us out.
Pika!
Hi there, Ash. Hey, May, what's new?
Hi, Ada. We actually just stopped to give our Pokemon a snack, and we need to figure out how to split this berry so that each gets an equal part.
No problem. I'll help you through it.
Thanks, Ada.
Okay, so what we are talking about is a part of a whole. Let's look at your berry as our example. The berry is a whole. Now, if it is cut into 4 pieces, each piece is a part, or fraction, of the whole. Each piece is 1 out of 4, or 1/4. So, The number on the bottom of a fraction is the number of all the pieces that make up the whole. That number is called the denominator.
Okay, so we cut the berry into 4 pieces. So the denominator, or total number of pieces, is 4.
What's the number on top of the fraction?
That's the numerator. The numerator tells how large the fraction is.
I got it! Each Pokemon is getting 1 of 4 pieces of the berry. Each Pokemon is getting 1/4 of the berry.
You guys are doing great! Why don't you figure out some more problems with fractions?
Awesome!
Ready, guys?
Okay, first one. If we split the berry into 2 pieces, what fraction would we have?
If you split something in 2, each piece is 1/2.
Let's try some more problems.
What if we wanted to share the berry with 5 Pokemon? What fraction of the berry would each Pokemon get?
Okay, what's up with the audio quality on this segment? Man, this sounds much lower quality than the rest of the lesson.
If you split something in 5, each piece is 1/5.
What if we wanted to share the berry with 3 Pokemon?
They had to
What fraction
compress
of the
it because
berry
it was
would
too
each
large.
Pokemon get?
If you split something in 3, each piece is 1/3. What if we wanted to share the berry with 4 Pokemon? What
AKA
fraction of
the
the berry
original
would each
problem.
Pokemon get? If you split something in 4, each piece is 1/4. Good job, guys. I'm sure your Pokemon have worked up an appetite.
No fractions here. I want 1 whole of this sandwich.
Yum!
Oh,
Munchlax.
Well, thanks for your help anyway. You're great at fractions.
Are you ready for a challenge on your own? See if you can match the fraction and the number. If you can, there's a hidden picture underneath.
See, audio quality goes right back to normal. I have no idea what was up with them in the second part.
Good job! See you next time!
Well, like I said, this was the simplest lesson they ever did. And really, it was not much of a wasn't much of a plot besides they were hungry and needed to split the food between their Pokemon. Well, yeah, you don't have to guess, but some of the later lessons do this much but better. And now one watching on as I set them up the last 2 lessons. And see just
You might need to use scratch paper.
Oh, yeah!
Now you're getting it.
Whoa, what a wipeout! I hope Brawly's okay.
Pika!
Man, that was some wave. I got crushed.
At least you're okay. That's what's most important.
Yeah, but my board's totaled. Major bummer. I'm landlocked, dude.
We gotta do something. Hey, look at that! The Wave Rider Extreme! Maybe we can all pitch in and get Brawly a new board as a present. But I saw the same one at a different shop yesterday. Maybe I should go there instead? I think a surfboard is pretty expensive. Let's call Ada. She'll help us figure it out. Hi, Ada.
Hey, Ash, what's up?
Well, I'm checking out surfboards for my friend Brawly at different shops. Surfboards can be expensive, so I'm trying to figure out which one is cheapest.
Shopping? No problem. I'm an expert. So let's talk about what you would do to compare how much the boards cost, their price, at the different shops. To start, what if I told you I saw 3 different prices, $200, $180, and $150? Which would be cheapest? Right! But that price isn't always the final price. Sometimes you see a sign that says some percent off. For example, 20% off. And that means a sale. A sale can mean big savings or just a few dollars off. To figure it out, you need to check the regular price and the percent off or discount. They both affect the final sale price.
So, how do I figure out the rest?
No sweat. In fact, once I got it down, I was using percents to figure out discounts all the time. Like yesterday, I got this great pair of shoes on sale, and then, when I was walking back to the lab, I saw another sale with this awesome bag. And of course, I had to get it because it went with the shoes and...
Ada?
Oh, sorry. It's just such a great thing to know, and I just love a good sale. So here we go. Let's say a surfboard regularly costs $200, and on sale, it's 25% off. To calculate the reduced sale price, we first have to find 25% of $200, and then subtract that amount from the regular price. I call that descent by the percent.
Okay, so step 1. 25% of 200?
Can you give it a try? How do you find the percentage of a number?
Oh, you multiply the number by the given percent.
Right. 25% of 200 is the same as 200 times 25%.
But how can I multiply a percent?
Percents can be written in different ways. I usually change the percent to a decimal. To change a percent to a decimal, drop the percent sign and move the decimal point 2 places to the left. Now, get ready for some multiplication calculation. Okay, in goes the regular price and our decimal percentage, 0.25. Now, let's calculate. Don't forget, the number of decimal places in the product equals the total number of decimal places in the factors.
Got it! So the decimal point goes 2 places to the left. Cool! 25% of 200 is 50. But we still don't know the sale price.
It's time for step 2. We have to subtract the percentage amount from the regular price to get the sale price. Remember, descent by the percent. In goes the regular price and the percentage amount that we have to subtract. Get the numbers straight, then calculate. So the price of a surfboard that regularly costs $200 but was on sale for 25% off would be
$150.
Oh, well, that was an abrupt way to end the first part. But enough about that.
Now you're getting it. How about trying out a practice problem? I'll give you another example. This time, we'll make the regular price $190 and the sale 30% off. So, what's the sale?
What's the first thing we have to do?
Click on the step to take. If you need help, click the Sale Steps button.
According to step 1, we have to start by finding 30% of 190. So we have to multiply.
Click Multiply. Now, drag numbers into the boxes to fill in the regular price and the decimal representation of the percent. When you're finished, click Calculate.
And no, I kind of won't wish they. No, I kind of won't wish they let you just type in the numbers instead of just dragging them in like this. It would make doing it a bit that much much easier.
Good job!
Yeah! 30% of 190 is 57. Now for step 2.
Click Subtract.
Okay, here we go. Fill in the regular price and the percentage amount to subtract.
When you're finished, click Calculate. There you go!
Awesome! The sale price is $133.
100% correct! You're ready to go, so shop till you drop.
Oh yeah, I'm ready now.
Hey Ash, you busy?
Brawly, I was just thinking of you. What's up?
No action here, dude. None. Nada. Zip. Boy, I sure miss my board.
Don't worry, Brawly. I have a feeling your luck's about to change.
Sure hope so, pal. I'll catch you later.
Now you're getting it.
Oh yeah! Brawly's gonna be so pumped when he sees his new board. Are you ready? Oh yeah! Brawly's gonna be so pumped when he sees his new board. Are you ready to do some board shopping? Pikachu! Here you go. Check out this info. It's from the first store.
Multiply first to figure out the percent amount. Fill in the correct numbers, then calculate the multiplication.
Oh boy, there you go.
You got it. That's the percentage off amount. On to the subtraction.
Fill in the correct numbers, then calculate the subtraction.
Awesome! Now we know the sale price of the Wave Rider Extreme at this store. Okay, on to store 2.
Fill in the correct numbers, then calculate the multiplication.
You got it. That's the percentage off amount. On to the subtraction.
Fill in the correct numbers, then calculate the subtraction.
Awesome! Now we know the sale price of the Wave Rider Extreme at this store. One store to go. Here's the sale info.
Fill in the correct numbers, then calculate the multiplication.
You got it. That's the percentage off amount. On to the subtraction.
Fill in the correct numbers, Then calculate the subtraction.
Awesome! Now we know the sale price of the Wave Rider Extreme at this store. Alright, you figured out the information we need. Now let's compare the sale prices for the 3 stores. Click on the store with the best price for the Wave Rider Extreme. Excellent! Hang 10 definitely has the best deal. Come on, let's go. Wow, this board's great. Brawly's gonna be so surprised.
Oh man, I can't believe it! A Wave Rider Extreme? Totally awesome, dude!
Glad you like it, Brawly. There's nothing better than a happy surfer, dude. Thanks, pal, for helping me pull it off.
Well, that's what. But what are you gonna do? Hey, always gotta have a happy ending for these kind of things. Well, now it's time to move on to our fifth and final lesson of the night. Now, where we'll help Misty learn how to find the area of a circle.
Here you go, Psyduck.
Psyduck.
That's the 3rd time you fell in this week. We're going to have to put a cover on this tank.
Psyduck.
Of course, you could just stop playing with the water, but I think covers may be better. I'll make sure you're safe.
Psyduck.
Now, I just have to get a measurement for the size of the cover. The cover needs to fit across the top of the tank. With the rectangular tanks you fell in, it was easy. I just multiplied the length of the tank by its width. That gave me the area of the top of the tank. That was the size we needed for the cover. But how do we find the area for a tank in the shape of a circle?
Psyduck.
We're going to need some help with this. Let's use the Pokepilot to contact Ada. Hi, Ada.
Hi, Misty. How are things?
Things are good. Well, maybe not for Psyduck. I have a problem, and I thought you might be able to help.
Sure. What's up?
We've been making covers for some of the Pokemon tanks. They keep Psyduck from falling in the tanks.
Psyduck.
Well, that sounds like a good idea. So what's the problem?
To make the covers, I need to know the area of the top of the tank. I know how to find the area for a rectangle, but we have a lot of circular tanks. How do I find the area for the tops of those tanks?
I can help you with that. So first, tell me about the tank.
I'll show you. It's a tank with a round top that is 2 meters across.
Okay, so if it's 2 meters across, we say its diameter is 2 meters.
Huh?
Psyduck.
Yep. The diameter of a circle is the length of a straight line from one point on the edge of the circle through the center of the circle to another point on the edge.
Okay, so the diameter of the top of this tank is 2 meters?
That's right. To find the area of the circle, though, we need to find the radius. Do you know what the radius of a circle is?
I think so. It's like a ray of light. It goes from the center to the outside?
That's a good way of thinking about it. It's the distance from the center of the circle to an outside point. It's also half of the diameter. So in this case, the diameter is 2 meters, meaning the radius is
1 meter.
Psy.
You got it. We can use this radius in the formula for finding the area of a circle, pi r squared.
Psyduck.
Sounds funny, doesn't it? R stands for the radius, your ray from the center. R squared means you multiply the radius by itself, or square it. And then pi is the ratio of the circumference of a circle to its diameter. Remember, the circumference of a circle is the measure all around the edge of the circle.
And so pi is actually a number, 3.14. To find the area of the top of a circular tank, you would multiply pi by the radius squared.
Okay, for this tank we would multiply pi by 1 squared, since the radius is 1 meter. 1 multiplied by 1 is 1. So the area of this circle is 1 pi.
That's it. Now all you have to do is multiply 1 by pi, or 3.14.
That is 3.14 square meters.
Great work! You'll need 3.14 square meters of material for the top of this tank.
Great! I can make sure we get enough cover material for this tank. But we should probably cover another tank just to be sure.
Sorry.
It's okay. Would you help me find the area of another circle for tank covers? Let's do it. I need to find the area for another tank. Will you help me?
It is the formula for the area of... What is the radius of a circle?
I need to find the area for another tank. Will you help me?
It is the formula for the area of a circle. Try again. Right! The area of a circle is the radius squared times pi. What is the radius of a circle? Is it the distance around the outer edge of the circle? The distance from the center? Right! The radius of a circle extends from the center to the outer edge of the circle. The diameter of this tank is 20 decimeters. What is the radius? Right! The radius is half of the diameter, or 10 decimeters. What is the radius? 10 decimeters squared. Right! 10 multiplied by itself is 100. What is the area of a circle with a radius of 10 decimeters? Right! The radius squared is 100, and 100 pi is 314.
You guys did great! Are you ready to try a bigger challenge?
You might need to use scratch paper or a calculator for this challenge.
Psyduck needs help getting across this path. There are holes on the trail. Don't let Psyduck fall in. To fill in the hole, drag the correct circle to a hole by finding the area, radius, or diameter of the hole. Wrong circles just won't stay in place. Help Psyduck! Fill these holes with more circles. Try again. Excellent. Help Psyduck! Fill these holes with more circles. Excellent. Help Psyduck! Fill these holes with more circles. Great! Help Psyduck! Fill these holes with more circles. Awesome! Help Psyduck! Fill these holes with more circles. Try again.
Try again. Great! Which circle will fill the hole in the path? Try again.
What the heck?
Excellent! Which circle will fill the hole in the path? Excellent! Here are more holes to fill. Excellent! Help Psyduck! Fill these holes with more circles. Try again. Excellent! Help Psyduck! Fill these holes with more circles. Try again. Awesome!
Now you can use the area of a circle formula to find the right size for the covers and anything else you might need.
Thanks, Ada. Now we'll be able to keep Psyduck dry and safe.
Glad I could help. Bye.
See
See ya! Okay, Psyduck, let's make some more covers.
Psyduck?
You might need to use scratch paper or a calculator for this challenge.
Let's give it another go.
Psyduck needs help getting across this path. There are holes on the trail. Don't let Psyduck fall in. To fill in the hole, drag the correct circle to a hole by finding the area, radius, or diameter of the hole. Wrong circles just won't stay in place. Which circle will fill the hole in the path? Awesome! Here are more holes to fill. Awesome! Help, Psyduck! Fill these holes. Great! Help, Psyduck! Fill these holes with more circles. Great! Help, Psyduck! Fill these holes with more circles. Try again. Try again. Great! Which circle will fill the hole in the path? Try again. Try again. Awesome.
Why do I keep getting...
Help, Psyduck! Fill these holes with more circles. Awesome! Here are more holes to fill. Great! Which circle will fill the hole in the path? Try again. Awesome! Which circle will fill the hole in the path?
Try again. Try again. Excellent.
It's...
Now you can use the area of a circle formula to find the right size for the covers and anything else you might need.
Thanks, Ada. Now we'll be able to keep Psyduck dry and safe.
Glad I could help. Bye.
See ya! Okay, Psyduck, let's make some more covers.
Psyduck?
You might need to use scratch.
Nah, no, we're not gonna do that again. Hey, not gonna lie, I did get dumped them there a few times. But no one said that math was easy. But then again, nobody said math was easy. Now did them? Anyway, but enough about that. That brings us just to the end of another edition of the Pokemon Learning League Tuesday. Remember that next week we'll be tackling the first 5 lessons in the language arts category. But the streaming fun isn't over yet. Tune in tomorrow at 7 for this week's edition of Humongous Entertainment Wednesdays. Don't know why I almost said Sundays there. Anyway, tune in for this week's edition of Humongous Entertainment Wednesdays, where we'll be playing through Pajama Sam and No Need to Hide When It's Dark Outside, and Spy Fox and Dry Cereal. Until tomorrow, this is MediaNutso saying, I'll see you next time.